Okay, so good afternoon, class. It's Sir Gerald again. Uh, for today, we will be actually delving into another part of analytical geometry, wherein we will be looking into polygons, which are actually drawn on a Cartesian plane. So basically, for today, we will be actually using our different discussions earlier this as final starts. So in that, I actually have here a polygon which is actually a pentagon. Meron tayo ditong pentagon, A, B, C, D, E, wherein we are actually asked to get the perimeter of the pentagon A, B, C, D, E. So in here, as you may have noticed, our pentagon actually have ordered pairs as their vertices. So we have here line segments, points A to E, and we also have here line segments A, B, C, D, E. So as of now, maaring nakita nyo na, ayan na, gagamitin na natin yung distance formula na ang tagal-tagal nang natigil kung paano natin siya gagawin. So basically, when we are talking about perimeter, it is just the sum as our sum definition. Perimeter is actually just the summation of all the lengths, summation of lengths of all sides of our polygon. So basically, we just need to add the lengths of line segment AB, line segment BC, line segment CD, line segment DE, and line segment AE. So, in that, yun yung gagawin natin. We just need to get the distance between each points, and after getting the distance from each points, we will be just adding them. So, we will have the perimeter for our pentagon A, B, C, D, E. So, in that, let me just write that. So, for the perimeter of pentagon A, B, C, D, E, we will be just getting the distance of AB plus the distance of BC plus the distance of uh, CD plus the distance of DE, and lastly plus the distance of uh, we have here AE. Okay, so let's get to it. First, we need to calculate this distance. So for that distance, as you may have remember, our distance formula is just the square root of the changes in x, which is, we can write this as x2 minus x1 square plus the change in distance in y. So we have here y2 minus y1 square. And after getting that square root, we have here our distance. So in that, let's first do distance of AB. Okay. So for distance of AB, let's just take B as our second point. So our x2 will actually be -5. Then minus x1, which is -1. Okay. Oh, sorry. That should be minus -1 minus -1. Then we will square that. And we just need to add y2, which is 1, minus 4. So, square. Then we just need to get the square root of that. So, if you're ahead, so this will be 6 square. Tama ba? We'll have here -5 plus 1. Ah, no. should be 4 square, negative 4 square. So we have here 16. Then we have here 1 minus 4, that will be 3. 3 square will be 9. So we will have here a square root of uh, 25. And square root of 25 is equal to 5. So we have here our first distance, which is 5. So this will be 5. Okay. Next, let's compute for BC. This one. Okay. So for BC, that will be equal to our excess. So we have here negative 5 minus negative 5. Okay. That will be 0. Plus, we have here negative 3 minus, do we have here 1 square. So that will be 0 because this will be positive. So we have there 0 squared, that's actually 0, plus we have here 4, uh, negative 4 actually, negative 4 squared, that will be 16. Okay, and we have here square root of 16 is actually 4. Okay, so we have here 4. Next, we have here the distance of CD. Okay, so again, same concept. We have here 1 minus negative 5 square, 1 and negative 5, plus we have here negative 3 minus, of course, we have there negative 3, again 0. But for the sake of computation, we will have here uh, negative 1 minus minus 5, so that will be 1 plus 5, 6. 6 squared, that will be 36. Plus, this will be negative. Minus minus, that will be plus. Meaning to say we have there 0. Okay. In short, we have here square root of 36, which is actually just 6. Okay. So this will be 6. And for the next part, we have here the distance of DE. Same concept. We have there 3 minus 1 square, plus we have here 1 minus negative 3 square. So this will be 2. 2 square is 4. And we have here minus minus, so that will be 3. 4 plus 4, that will be 4 times 4, that will be 16. Okay. So we have here plus 16. We have here square root of 20. So in that, we actually have square root of 20. Square root of 20 is actually equal to, if we rationalize that, that will be equal to square root of 4 times 5. And 4, square root of 4 is 2. So we will have here 2 square root of 5. So for the last part, we have here the distance of uh, A and E. So what we'll have in here. So for the distance of A and E, this will be just actually same concept. Let's use 3 as our second point. So we will have here 3 minus negative 1 square, plus we'll have here 1 minus 4 square. So So that will be equal to, this will be positive 1. So 3 plus 1 is 4. 4 squared is 16. Again, we have here, this will be negative 3. Negative 3 square will be 9. So we will have here square root of 25, which is actually equal to 5. So in that, we actually have all the measurements that we need for this formula, or for the computation of our perimeter. So for line segment AB, we have 5. For line segment BC, we have 4. For line segment CD, we have 6. For line segment DE, we have 2 square root of 5. And lastly, we have 5 for our line segment AE. So in that, we just need to calculate the overall perimeter of our pentagon. So our pentagon actually have a perimeter of 5 plus 4, which is 9, plus 6, that will be 15, plus 5, that will be 20. So this will be actually equal to 20 plus 2 square root of 5. As you may have noticed here, I did not use decimal points for our 2 square root of 5. So it is the best practice in our class that we don't actually get the decimal form of our square roots. It is better if we express them in rational form. So in that, we actually have the perimeter of our pentagon ABCDE. So basically, we just used our distance formula to calculate for that perimeter. So I will be giving you some other problems that is related to this problem. So wherein you will be using distance formula. Okay, bye.